Hi guys, so let's revise through the periodic table content together and hopefully that will help you in preparation for your assessment. I don't want to do the assessment too early because I want you to make sure that you really understand this content, because otherwise there's no point of doing an assessment just for the sake of it. So what I'm going to do is, before I go on to look at the periodic table content itself, what I'm going to do is go over that year 7 content that you would have looked at last year. I know it seems like a long time ago, but it's important to understand the basics of chemistry before we go on to look at the periodic table in more detail with the year 8 content. So in year 7, what you would have done is you would have had a look at elements, atoms and compounds. And I've just taken this knowledge organizer from the year 7 booklet, and you would have done exactly the same thing. So you would have started off by looking at atoms, and if you remember, everything is made up of atoms. And generally, atoms look a little bit like this. They have a nucleus in the middle with the positive protons, and the nucleus also contains our neutral neutrons. And then what we have are shells surrounding the nucleus. And these shells will contain our negative electrons. And some higher level content, which some of you might have looked at last year, is that there are a number of shells within atoms. So atoms can have loads and loads of shells. But the first shell always after the nucleus can hold a maximum of 2 electrons, and the second shell can hold a maximum of 8 electrons. It can have less electrons depending on the type of atom it is, but the maximum number that all the shells after the first shell can hold are 8 electrons. So the third shell will be able to hold a maximum of 8, the fourth shell will be able to hold a maximum of 8. It's only the first one that is 2, the rest are 8. But don't worry if you don't remember this, we will go over why this is important later on, but for now, just remember the structure of an atom and the subatomic particles. You would have then had a look at elements, and if you remember, each element is made from only one type of atom. So the periodic table is made up of elements, and the elements that you see on here are the same type of atoms joined together. So for example, lithium will only have lithium atoms. Sodium will only be made up of sodium atoms. And elements also have chemical symbols, which we can see on the periodic table. So for example, copper is Cu, zinc is Zn, etc., etc. And then you would have had a look at compounds, and compounds are made from 2 or more elements that are chemically bonded together. So for example, we have carbon dioxide, we have carbon and oxygen making up carbon dioxide because it's chemically bonded together. In water, we have hydrogen and oxygen chemically bonded together. And then moving on from this, linked to the compounds, you would have had a look at chemical formulae. And chemical formulae tells us which elements are present in a compound. So for example, H2O, which is water, has 2 hydrogens and 1 oxygen, so we write it as H2O. And methane, which is made up of 1 carbon and 4 hydrogen, we write as CH4. And this is just a recap, so this should hopefully jog your memories a little bit. And then you would have had a look at the periodic table, not in too much detail, but you would have just familiarized yourself with the different elements and where they are, etc. But you might have found it really hard to find some elements when you were in year 7. And you might have wondered why why do they sit where they are? So how are they arranged? Why are they in a specific position? And the year 8 topic looks at this, explores this in more detail, and hopefully as we go through the unit, you will be able to answer that yourselves. So let's move on to have a look at our booklet. So this unit, in the first lesson, we look at metals and non-metals. Then we look at how elements are arranged in the periodic table. Then we look at group 1 elements, then group 7, then group 0. In this video, I'm just going to focus on lesson 1, and then I'll do more videos on lesson 2, 3, 4, and 5. So don't worry, all the content is coming. So let's go on to lesson 1. The do now task I already went through in class, so it's just based on year 7 stuff. If you are still struggling with that, just let me know and I will be able to go through it with you. But going on to the new information and metals and non-metals. So here is a picture of a Russian scientist called Mendeleev. And in 1896, which is quite a long time ago, Mendeleev looked at different elements. He looked at the properties and the patterns those elements showed, and he arranged them into the periodic table that we see today. But at the time, there were only 60 known elements. Now there's 96, so we have 96 elements that have been found to exist naturally. So we've just added the elements on in the same way that Mendeleev laid out. But Mendeleev actually knew that new elements, well, he predicted that new elements would be found. So he actually at the time left gaps so they could be later added in. So when we look at the periodic table, how do we know if an element is a metal or if an element is a non-metal? So we've got a little trick here. What we can do is we can draw a stepping line, so the red line that you can see on my screen that I'm just going over. We can draw this stepping line which kind of looks like steps, quite self-explanatory, and everything on the left of that line is generally a metal, and everything on the right of that line is generally a non-metal. I say generally because there are some odd elements that don't fit that pattern. So don't take it word for word, it is generally, and we use it to help us, but we can't rely on it 100%. So what we do is to find out more, so to explore whether an element is a metal or a non-metal, we have a look at the properties of those elements. And metals will have slightly different properties, and non-metals will have slightly different properties. So metals would be good conductors of both electricity and heat. They would be shiny, they would have a high density, so that means that they would be heavy for their size. They would be malleable, so you can hammer it into different shapes. They would be ductile, so you can pull it into wires, and they'd be sonorous, so when you hit it, it makes a ringing sound. But non-metals, they would be poor conductors of electricity, they would be poor conductors of heat, they would be quite dull, they would have a low density, they would be brittle, so they would break easily, and not sonorous, so they don't make that ringing sound when they're hit. And usually, so I say usually, don't take that word for word, so I'm just telling you what generally we find, is that metals at 20 degrees Celsius, they're usually solid, and non-metals are usually gases at 20 degrees. So that is another difference that we have. Some elements will have some properties that would match with metals and some properties that would match with non-metals. So that might leave you a bit confused as to which category we would put in. What we do is we refer to these elements as metalloids. And metalloids can have some properties of metals and some properties of non-metals. So they're like the in-between ones. And they're usually found on either side of the stepped line, so on like right next to it. So we can't put them into a metal category or a non-metal category, so we just call them metalloids. Having a look at some of the chemical properties of metals and non-metals. So both metals and non-metals can react with oxygen. So when metals react with oxygen, they would form metal oxides. So for example, magnesium plus oxygen goes to magnesium oxide. When non-metals react with oxygen, they form non-metal oxides. So for example, sulfur plus oxygen goes to sulfur dioxide. And most metal oxides, so the metal oxides at the top, they will be solids at 20 degrees. Sorry, let me write that properly. Solids at 20 degrees Celsius. And they're quite basic. So basically means that when you dissolve them in water, they form alkali solutions. And alkaline solutions, they have a pH of more than 7. And non-metal oxides, so the ones at the bottom, these are usually gases at 20 degrees Celsius. And when they dissolve in water, they form acidic solutions, and acidic solutions will have a pH of less than 7. And sulfur dioxide and nitrogen dioxide, they are examples of acidic gases. And they're sometimes formed when, do you remember in our energy topic, we had a look at fossil fuels? So when those fossil fuels are burned in the powerhouses, etc., they can sometimes form sulfur dioxide or nitrogen dioxide, which are acidic gases. And these acidic gases can dissolve in the rainwater and cause acid rain. We kind of had a look at this in our topic where we were looking at that weathering in rocks. We spoke about acid rain slightly, but an acid rain can harm our organisms in our water, in our lakes, in our seas, etc. And it can also damage trees and buildings. So if you remember those rocks when from our topic before, when acid rain hit them, they weathered, so they broke down. So basically that is all that you need to know for this lesson. Just to give you an idea of some of the things that you will need to know. So you should be able to identify if an element is metal or a non-metal if given the properties. So for example, in an exam, they might say element X is shiny. So you would automatically know that metals are shiny, so element X must be a metal. So it might give you different scenarios like that. Let's have a look at, you would have already done these questions, but if there's anything particular you're struggling with, again, just get back to me. It's just looking at the properties in more detail and the chemical properties in more detail. But that's it for this lesson. Hopefully that helped. Any problems, do drop me an email. I will make another video on lesson 2 now, so stay tuned for that.